Hi, welcome to another video. Today I'm going to show you how to write to an SD card, update a text file, update the size of the text file, and then read it back. And I'll show you what the text file looks like on the PC as well. I nearly forgot, special thank you to Joaquin for your generous donation. So this program's not quite finished. It's currently reading 3 text files. There's a function in the C file below, just uncomment it to read more than 3 files. What I haven't allowed for is, as the number of files progresses, some of these numbers shift too far or don't move, but you can adjust that yourself. So at the moment we're looking at 3 files on the SD card. The function picks up the file names automatically. These locations in blue are the start of the name in the root directory. This location in green is the location of the text file. That's just the name of the text file, and you can see it was the 3rd file to be found. Text file size 14, so that's 14 bytes. 14 bytes, hexadecimal. This is what you would see in the hex editor if you open it on a computer. Hexadecimal E14. But Windows 10 will actually show this file as a 1K file. It doesn't show numbers under 1K. The text starting cluster is 311. That's in the root directory. I've explained how to find that in my previous FAT16 videos. With the maths to calculate the actual sector on the SD card is here, flashing white and blue. Just have a look at the C file. So this is the actual sector on the SD card. If I take the SD card out, put it onto the computer, open HXD editor, go to this sector, I'll find this text file. I'm not using an SD card or multimedia card library. I'm writing raw SPI. It's subject to errors. Now the errors on this particular card, I get an error writing command 17 and 24. When I swap the card, put this other one in down here, those errors don't appear. But since I formatted this to FAT32 for demonstration for you guys, this now no longer works correctly. I cannot reliably update the root directory once I've written data to the text file. Let me show you this file on the computer. So it's 14 bytes, this is saying, and so is the root directory. Let me show you. Right, I've put the SD card on the computer. Here's the card down here. Text, Nubix, resources, and Paris 1 bitmap. Text, let's open it. So Windows is showing that as 1K. And you see at the top, hello YouTube. That's all it says. I think my system said 14 bytes. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, including a space. So my system is accurate. So the root directory is accurate to the byte. Open HXD editor, card 2, root directory, which is 472. There's a test text, and there's the size there, E, 14 bytes. And looking at that flashing number, it was reporting the actual sector is at 20,280. So up here to sector 20,280, enter. There we go. There's the file. Totally empty. So here's my main. Lots of variables. There's 2 functions to read the sector and initialize card. As I say, no library, just raw SPI. This bit gives you the card name you saw at the beginning. This bit automatically picks up the files, but I've set it to a maximum of 3 at the moment. You can uncomment this and it will read the 2nd sector of the root directory. That's displaying the information. It does what it says. So if I get down to the nitty gritty, This is the maths for working out the actual sector where your text file is. Have a look at this top one, for example. The root directory in bytes. We need that to find the sector. Is a root directory shifted left 9 places. That's the same as multiplying it by 512. Anyway, there's the maths. I'm not going to bore you with it now. So similar to reading data from the SD card, except today we're writing. So we set the byte size to write at 512, hexadecimal 200, and then using command 24, we write to this address. So the address, which you saw earlier, is the actual sector plus the actual sector extension. Once you've got space in a text file, you can choose not to write at the beginning of the sector. You can choose, to come in like 512 bytes. So you'd come in once. If you hit 2 for the sector extension, you're coming in 512 bytes times 2. So if you've got a large text file, you're just leaving space at the beginning. That's what this is. Leave it at 0 for the moment. So the actual sector, I've got it as a structure. So we've got the actual sector dot sector plus the actual sector dot sector extension. So the extension is just if you want to leave some space at the beginning of the file. Right, so what I'll do now, I'll show you on the TFT. I'm going to write this here, which is writing, if you're familiar with ASCII, it's writing 65 to 90 in ASCII. That's capital A to capital Z. And it's going to do that 512 times. So that will fill up the first sector of the text file with A to Z. However many characters we can get in 512 times. Let me go back to the screen. Right, so I'm going to plug this card in. I've extended the delay so we can read some data. So it's obviously got to read the boot sector and everything. JB card 2. Now I've shown you some of the code. So I've put the memory card back in. I've put a delay so it doesn't continue yet. We've still got 14 bytes in the text file. The actual sector on the SD card, 20,280. 14 bytes. No errors as yet. This is going to write the A to Z as many times as it can within 512 goes. Then this is going to jump to this sector and read that sector back. This program at this minute is not going to update the root directory. So let me show you what happens if we don't update the root directory. I'll take this loop out. So the boot information will come up first. We obviously need that to find the root directory. There's the root directory, 472, JB card 2. That's our actual sector. So it's going to write the A to Z here and not update the root directory. Right, so the text is written. Look for the first character up here, 65, 66, 67. So ASCII character 65 is an A. And the last character it wrote, ASCII character 82. It's got to reset so it can read the root directory again. Remember, it didn't update the size of the file, but this says it wrote to that sector. So we've still got 14 bytes. Now let me take this SD card out, put it on the computer, and show you what happens when you don't update the root directory. Oh, and we've got one error. The last command, 17. File Explorer, JB card 2, test text. My system said it wrote 512 bytes. But look, we've got A to N. How many bytes is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. What goes on? We didn't update the root directory, so when this computer looks at the root directory, it still says 14 bytes, so the computer only looks at 14 bytes. That's straightforward, isn't it? Now open HXD32exe, open a card, JB2, go to 472, the root directory. There is the size. still at 14 bytes. Remember, F is 15, so E must be 14. We didn't update this. Let's jump to sector 20,280, where it says it wrote the data. 20,280. Enter. There you go. We've got 512 bytes there of A to Z. Have a look. P, Q, R, S, T, U, V, W, X, Y, Z. So there's one lot, then another, so on and so forth. That's sort of proof that if you don't update the root directory, you'll have trouble with Windows. But there's a way around it. This is a little cheat if you can't be bothered to update the root directory. You only need to update the size. So if you get a notepad and draw, I think this is an underscore. Let me just try it. Yeah. So it's shift and the hyphen, which is an underscore. If you keep on, let me shut that down without saving it. If you write this file to your SD card, it's all of a sudden a few kilobytes large, and then you're able to fill this first bit with A to Z, or whatever you want, then another bit. What I was talking about by this sector extension, so the first 512 bytes will be somewhere here, the second will be here, and then the third, and then the fourth. So with the extension, I've put that in there because you might want to write, say, 512 there, jump one, and then right there. That's what the extension's about. So it's a little cheat. If you don't want to update the root directory of the file size, just put a big text file in there to begin with. Right, I put the original text file just with the hello YouTube, so 14 bytes. I've put that back in. Now it's not going to bypass the update root directory. It's going to update the root directory, increase the size by 512 bytes, and when it reboots and rereads it, you'll see the increase. So watch carefully to the size over here somewhere. Root directory, same card. Right, watch for the size. E, still 14 bytes. I'll put a longer delay. There's a text file. Right, it's written the data. Updating the root directory. Now it's going to read the file back. "65, 66, 67. So that's it. It's written it all back. But now watch for the file size. There we go. 200 hexadecimal. Should remember if you've been watching my other videos recently. 200 is 512. So 512 plus E. That's obviously 526 bytes. What I'll do, I'll unplug it, but not move anything. Let me show you what happens. Watch the size. Written the file. Updated the directory. Now to read the file, we still should see ASCII character A up here. 65, and this is the last 100 bytes. There we go. Now that file size is 1038 bytes. Well, unplug it, plug it back in. So 1038, wrote the file to the same place. There we are, so we've still got the A to Z, but see, now look at the file size, 1550 bytes. yet we keep on writing to sector 0 of this file. So now I can use that actual sector extension and come in one or two places. So let me change the extension to 2. We'll see what happens with this number. Right, I'm changing the file extension to 3. Watch for the file size. Should be the same as before. Right, 1550. But now the extension is 3 lots of 512 on top of this. So see what happens. That's writing that address. You have to divide that by 12 to figure out the sector. So it's updated the root directory. We've got 1 error counter so far. Reading it back, still got character A in the first position. There we go, that's the file size, 2062, but notice my clever program, it's given us the sector that it actually wrote to last. So it was 20,280, it's now 20,283. So let me take this SD card out of this and put it on a computer. Right, File Explorer, test text. And the file size is now up at 3K. Remember I'm looking at my TFT, it says 2062 bytes. And I said earlier the Windows 10 reads every 1K. So 3K, open the file. There we go. I must have put the wrong file in here because there's a load of underscores there. I must have put the other file back. Anyway, there's the first sector we wrote to. And then I jumped 3 places. You'll have to forgive me, I put the wrong file back in. I put the one with all the underscores. And every time I write something, it's updating the file by 512 bytes. Let's open the HXD editor. Go to the root directory, 472, file size, E08, which is exactly what my TFT says. If you don't believe me, rewind the video and have a look. Now jump to sector 20,283. 20,283. That's the last sector I wrote. Scroll up the sectors. In fact, if I 20,283, if I go down here, use this arrow, that's down 1 sector. This has just got the full of underscores. Down another sector, 20,281. I can see there I jumped 2 sectors by putting in that number 3. I forgot because we already had 1 sector written. The original sector, 20,280, is there. We looked before it, just a load of garbage. Actually, I'm probably writing over some other file. That's the first sector there. Missed 2, and another sector there. The clever bit in the program is working out where your actual data is. The rest is, straightforward SPI. I say straightforward, but it took me weeks and weeks to get it working. So just before I go, I'll write one more message. So I'll find this text file. I'll delete everything, so Control A, delete, put something in there. Hello, YouTube. File, save. Right, that's now that file. Let's open it again. Yeah, hello YouTube. Saved 1K. I'll now put this back on my board, let the microcontroller write something new and see what happens. Well, I'll put the extension back to 0. This is now programming. Right, my microcontroller's just finished writing the new message. So remember, I deleted everything on that text file, just put hello YouTube. It's now back down to 1K. If I open this up, thanks for watching. Don't forget to hit like, see show more for link. I'll put the C file on GitHub and put a link in the show more. Well, the C file is still under construction. There's lots that can be improved, but it gives you a platform to improve it yourself. I've done all the hard work. If you want to make a donation for the hours and weeks of effort I've put into getting this working, the link is also in the show more. Thanks for watching. Don't forget to hit like. Thank you very much.